Hello, welcome to this video session of quadric surface for hyperboloid of one sheet. The hyperboloid of one sheet is a topic from the paper Analytical Geometry for 3rd semester CBCS, and its code is B.Sc 3036. It is presented by Dr. Barnali Deka, Department of Mathematics, Darrang College, Tezpur, Assam. So before we go to the hyperboloid of one sheet, we should know what is a quadric surface. So a quadric surface is defined in space by an equation of the second degree in x, y and z. The graph of a quadric surface is often determined by tracing graphs in xy plane, yz plane and zx plane. To form a quadric surface, we need to put all these three traces together. Now let us discuss a quadric surface hyperboloid of one sheet with the equation x square by a square plus y square by b square minus z square by c square equal to 1. So this is the equation for hyperboloid of one sheet. Let us draw the hyperboloid of one sheet for this equation. The equation x square by a square plus y square by b square minus z square by c square equal to 1. We are trying to trace or draw the graphs for this surface by using the graphs of this equation on three planes. The first one is let it be on xy plane. Let it be on xy plane. On xy plane, z is 0. So if z is 0, we get the equation becomes x square by a square plus y square by b square. Since z is 0, therefore it is equal to 1. So this is an ellipse. X square by a square plus y square by b square equal to 1 in xy plane. It represents an ellipse. So in the next case, we are trying to draw it for say yz plane. In yz plane. In yz plane, x is 0. In yz plane, x is 0. So the equation becomes y square by b square minus z square by c square equal to 1. So definitely it represents a hyperbola. Okay. Then again we are trying to draw the graph for xz plane. We are trying to draw the graph for xz plane. For xz plane, y is 0. Xz plane, y is 0. So if y is 0, the equation becomes x square by a square minus z square by c square is equal to 1. Again, it represents a hyperbola. So combining these three surfaces, we get combining all these three surfaces, we get the equation of the hyperboloid of one sheet, as we saw it in our next slide. So we get from this this equation, we get this type of surface. So from all these three surfaces we have already discussed, we get such type of figure known as hyperboloid of one sheet. Here for in x y plane, we have one ellipse here, In YOZ plane we have one hyperbola. Then in XOZ plane we have, similarly here we have another hyperbola here. So together all these three surfaces connecting here, we get this figure known as hyperboloid of one set. Then from all these three surfaces and from this figure we find these characteristics. All the three second degree terms are present there. Two second degree terms are positive and one term is negative. And so the surface in XY plane is an ellipse, and trace in YZ plane and trace in ZX plane represents hyperbolas. Axis of the hyperboloid will be parallel to the variable that is Z axis here. Now with the help of one example, that is x square by 25 plus y square by 16 minus z square by 9 equal to 1, we draw another hyperboloid by this way. So first we determine the trace in xy plane where z is 0. So this equation becomes x square by 25 plus y square by 16 equal to 1, as z is 0 here, as z is 0, for z is 0, these two terms remains only, and the equation becomes this one. So this equation can be written as x square by x square by plus minus 5 whole square plus y square by plus minus 4 whole square equal to 1. For here x intercept is plus minus 5, y intercept b is equal to plus minus 4. So putting these points, these 4 points from these A and B, we get 4 points. So putting these 4 points and connecting all these 4 points, we get such type of ellipse, so which represents an ellipse. So in XY plane we get one ellipse. Then this is the figure in 3D. This is the 3D figure where these 2 points are 5, 0, 0, and this one is 0, 4, 0, etc. Okay. Then we next we draw the curve for YZ plane. So in YZ plane x is 0. So if x is 0, the equation becomes y square by 16 minus z square by 9 equal to 1. So that can be written as y square by plus minus 4 whole square minus z square by plus minus 3 whole square equal to 1. So it is a hyperbola. Since minus is there, so it represents a hyperbola where y intercept is plus minus 4 and z intercept plus minus 3. So from these 4 points, we draw one rectangle here, and the two diagonals of these rectangles, which are the asymptotes for this hyperbola. So since y intercept is bigger than z intercept, therefore the hyperbola opens up in the right and left side of y axis. So 4, 0 is the vertex for right open up right curve, and minus 4, 0 is the vertex for the left curve. So we get this hyperbola. So this is the 3D figure where only this portion is visible for us. Now we draw or trace the curve for XZ plane. For XZ plane y is 0. Similarly, the equation becomes x square by 25 minus z square by 9 equal to 1. So that is x square by plus minus 5 square minus z square by plus minus 3 whole square, 3D figure. And after joining all these three surfaces, we find such type of figure which is known as the hyperboloid of one set. Here this one is x-axis, so we get one hyperbola here, this one is y-axis, we get another hyperbola here, and this is the x or y plane, where we get one ellipse. From upper side, the ellipse is given by this. Okay, so this is known as hyperboloid of one sheet. Next we are going to discuss the hyperboloid of two sheets in the next class. For today, thank you.